All right, our very last set of notes on factoring. So like I've mentioned before, there's a lot of methods to factor. So this is going to be the last one we're talking about, which is really just doing factoring in multiple steps if possible. So these are the steps we will take for any problem really at this point. These are going to be our 4 steps. So step 1 is to factor out the GCF if possible. If there is a GCF, you should take it out at the beginning because it will be a much easier problem since everything you have left over will be much smaller. So that's what you always want to do first. And then really the rest is kind of depending on your problem. So step 2, if you can recognize that you have one of those perfect special product patterns where you would have a plus b squared or a plus b times a minus b that we covered in our last set of notes. If you have one of those special patterns, then you can skip the box method and just finish out that special pattern. Step 3 is if once you have your terms left over, if there's 3 terms, you'd use the box method to finish out the problem. And step 4 is if you are somehow left over with 4 terms instead of 3 terms, we're going to solve by grouping. And I'm going to show you what that means today. You haven't seen solve by grouping yet. So here, solve by grouping is going to be our first one. So like we said in our first steps, we want to take out a GCF if at all possible, but it has to be common amongst all 3 of our terms, or all 4 of our terms in this case. And in this one, I don't have any common factors larger than 1 that's common between all 4 terms. So I don't have a GCF I can pull out that would help me. Then you don't know how to factor by grouping, so I'm going to go ahead and show you at this point. I'm going to divide this up into 2 pieces instead of tackling it all at once, 2 groups, if you will. That's why it's factoring by grouping. And I'm going to pull out a GCF for my first set and my second set. So for my first set, the greatest common factor I can pull out is x squared, and that'll leave me with x plus 3 in my parentheses. For my second group over here, my greatest common factor I can pull out is a 2, and that'll leave me with x plus 3 in my parentheses. Now, what is nice about factoring by grouping is that if you do it correctly, this set of parentheses should be the same, which means we can rewrite it as x squared plus 2 times x plus 3. And now if I were to multiply these 2 binomials back out, I would get what I started with. So this is our final answer down here. And that's how factoring by grouping works. Now, sometimes they're not in the correct order for you to factor by grouping. So if I divided this one as is into 2 groups, I don't have any common factors here. So what I'm going to actually do before I divide it into 2 groups is flip these 2 middle terms. And now I'm going to divide it into 2 groups so that they each have a common term. So my greatest common factor for this first set would be x, and that'll give me x plus 1. And my greatest common factor for my second set would be y, which would give me 1 plus x. But luckily, since addition is commutative, x plus 1 and 1 plus x are really the same thing. So for this one, I would have x plus y times x plus 1 for my final answer. Okay, so that's factor by grouping if you end up with something with 4 terms. So now let's work on some problems where we're going to walk through all 4 steps from that first slide. So factor completely is what our instructions say. And step 1 in factoring completely is pulling out the greatest common factor you can from all 3 of your terms. So if I look at these 3 terms, all of my coefficients are divisible by 3. And then I can also pull out an x, it looks like, since they all have an x. So I'm going to pull out 3x in front, which will leave me with x squared plus 2x minus 6. Okay, now I want to continue factoring this trinomial here. Now my leading coefficient is 1, so that means I want factors that multiply to be negative 6 and add to be 2. So let's see, I could do 6 and 1, that would give me negative 5. Or I could do -3 and 2. That would give me -1 though. I don't think I have any factors that multiply to -6 and add to be 2. So actually, this is as factored as possible. This is completely factored at this point. So this will become our final answer. Okay, so let's try on this one. It looks like 7 would be my greatest common factor for my coefficients, and then I could also pull out an x squared. So I'll pull a 7x squared out front, and then I have x squared minus 4 inside. And then step 2 is to look for any special patterns. I do have a difference of squares here. X squared and 4 are both perfect squares. So I can continue factoring by doing x minus 2 and x plus 2. And at this point, I'm completely factored. I don't have any more polynomials that I could make smaller. I don't have a trinomial. I don't have a group of 4. I have these 2 binomials and my greatest common factor in front. All right. This one says solve the equation by factoring completely. So when you have an equation, you want it to be 0 on one side. So this one, I'm going to move that 10x to the other side, which will make it a -10x equals 0. And now I'm going to remove the largest common factor I can. So it looks like 2 goes into all 3, and I could also pull out an x. So 2x is my greatest common factor, and then I'm left over with x squared plus 4x minus 5. And then here is where I would want factors of -5 that add to be 4. So it looks like I could do 5 and -1, and that would work. So I'll have my 2x out front, my x plus 5, and my x minus 1. And now I'm completely factored. I don't have any trinomials or polynomials left. I just have my set of 2 binomials and my GCF out front. And then when it says solve, we're really trying to figure out what would make this 0. So what we use is called the zero product property, and that means that if any of these terms, since they're all being multiplied together, is 0, it's going to make the whole thing 0. So for this first 2x to be 0, x would have to be 0 to make this piece 0. For this piece, x would have to be -5 to make it 0. -5 plus 5 is 0. And for this piece, x would have to be 1 to make it 0. So that's what we're talking about when we're actually solving to find these solutions, is what would make each piece 0. All right, so at this point, you do have a 5-question Delta Math assignment to work on for factoring completely. Make sure you're going through your 4 steps. Those will help you factor any problem you come across.